From roadwork in construction to manufacturing plants and refineries and every conceivable job in between, thousands of workers are subjected to airborne contaminants. If allowed to enter one's body, these different contaminants can cause great harm to the respiratory system and other vital systems. While the human body has a natural defense system in place, it is no match for the harmful dust, mist, vapors, and other airborne contaminants that can be present in the workplace. To protect you from such hazards, the Occupational Safety and Health Administration, or OSHA, created the Respiratory Protection Standard 29 CFR 1910.134. This training program was created to help ensure you understand the requirements for using respirators, how to properly select, don, and use a respirator, and how to care for and maintain a respirator. Approximately 5% of all U.S. workers in about 20% of all work establishments wear respirators at least some of the time while they perform their job. These workers are employed at approximately 1.3 million establishments nationwide. A respirator is a personal protective device that is worn on the face, covers at least the nose and mouth, and is used to reduce the wearer's risk of inhaling hazardous airborne particles, which include dust particles and infectious agents, gases, or vapors. Certain respirators also provide protection for oxygen-deficient atmospheres. To provide the proper protection, employees must have a good knowledge and understanding of respirators. In the control of occupational hazards and diseases caused by breathing air contaminated with harmful dusts, fogs, fumes, mists, gases, smokes, sprays, or vapors, the primary goal should always be to prevent atmospheric contamination. Atmospheric control should be accomplished as much as possible by accepted engineering and administrative control measures, such as confining the work operation, installing ventilation systems, using water sprays and/or substitution of less toxic materials. These types of controls are generally regarded as the most effective methods to control exposure. When effective control measures are not feasible or while they are being instituted, appropriate respirators must be used. OSHA considers respirators to be the least effective means of exposure control for the following reasons. Respirators only protect if properly fitted and worn during the job. Respirators only protect the employee wearing the respirator and not the whole workplace. Respirators are uncomfortable to wear, difficult to use, and make communication difficult. The cost, which includes medical examinations, fit testing, training, and purchasing, can be very expensive. The OSHA standard applies to all occupational exposures to contaminated air where an employee is exposed to a hazardous level of an airborne contaminant. You are required by the employer to wear a respirator, or you are permitted to wear a respirator. Employers have 4 duties that OSHA has imposed on them. First, they should use engineering and administrative controls where feasible to control the hazard. Second, they must provide appropriate respirators at no cost to the employee if an atmospheric hazard exists. Thirdly, they must ensure the use of an appropriate respirator. And finally, an employer must create and institute a written respiratory protection program to comply with the OSHA standard. In any workplace where respirators are necessary to protect the health of the employee, or whenever respirators are required by the employer must establish and maintain a written respiratory protection program. The pre-planning of the implementation steps is necessary to establish the written program. This pre-planning is by design and intended to ensure the employer is safely using the proper respirator. The written program must contain worksite specific procedures and elements for required respiratory use. The program must be administered by a suitably trained program administrator. The program must be updated as necessary to reflect changes in workplace conditions that affect respirator use. Each workplace respiratory program will be different, but the program must contain certain items if applicable to the workplace, including procedures for selecting respirators for use in the workplace, medical evaluations of employees required to use respirators, fit testing procedures for tight-fitting respirators, procedures for proper use of respirators in routine and reasonably foreseeable emergency situations, procedures and schedules for cleaning, disinfecting, storing, inspecting, repairing, discarding, and maintaining respirators. Employee training in the proper use of respirators, including putting on and removing, limitations on their use, and maintenance. Procedures for regular evaluations of the effectiveness of the program allows for continuous improvements or changes to be made as necessary to maintain a protective program. Employers who allow their employees to wear respirators on a voluntary basis when not required by OSHA or the employer must implement limited provisions of a respiratory protection program. Employers may provide respirators at the request of employees, or they may permit employees to use their own respirators if use does not create a hazard itself. Employees must read and follow all instructions provided by manufacturer on use, maintenance, cleaning and care, and warnings regarding the respirator's limitations. Employees must choose a respirator certified for use to protect against the contaminant of concern. Employees should not wear a respirator into atmospheres containing contaminants for which the respirator is not designed to protect against. Employees should keep track of their respirator to avoid using someone else's respirator. Employers must establish and implement those elements of a written respiratory protection program necessary to ensure the employee voluntarily using a respirator is medically able to use the respirator, and the respirator is cleaned, stored, and maintained so it does not present a health hazard to the user. The voluntary use of a dust mask or filtering face piece does not require a written protection program. Employers must select and provide an appropriate respirator based on the respiratory hazard to which the worker is exposed and workplace and user factors that affect respirator performance and reliability. Respirators must be certified by the National Institute for Occupational Safety and Health, or NIOSH, and used in compliance with the conditions of its certification. With few exceptions, such as some filtering facepiece respirators, the NIOSH approval number is not on the respirator itself, but on a separate NIOSH approval label, which is found on or within the packaging. Both an approval label and user instructions are supplied with all NIOSH-approved respirators. These documents, a single copy of which may accompany either a large or small package of respirators, should not be discarded before all of the respirators have been used or discarded. In addition to the approval number, the NIOSH approval label contains contact information for the respirator manufacturer or supplier, the cautions and limitations for its use, and directions for proper use. It is extremely important to read and follow all of the manufacturer's instructions for any respirator you are about to use. If you don't understand something, ask your supervisor. When employees are exposed to respiratory hazards and/or are required to wear a respirator, an exposure assessment must be made. Employers must first identify and evaluate the respiratory hazard or hazards in the workplace. Employers must make a reasonable estimate of the employee exposures anticipated to occur as a result of those hazards, including those likely to be encountered in reasonably foreseeable emergency situations. When the employer cannot identify or reasonably estimate the employee exposure, the atmosphere should be considered immediately dangerous to life or health, or an IDLH atmosphere. Specific characteristics of the airborne hazard must be established in order to select an appropriate respirator. Is the contaminant a particulate, such as dust, fumes, or mist, or a gas, vapor? Is the contaminant a chemical? And if so, are there material safety data sheets available? Are there any mandatory or recommended occupational exposure levels for the contaminant? These questions must all be answered to ensure employee safety when selecting and using respirators. When employees notice symptoms or complain of respiratory health effects, or if the workplace contains visible emissions such as fumes, dust, or aerosols, an assessment should be performed. Many factors must be taken into consideration when selecting respirators. Workplace factors are very important to consider when it comes to respiratory selection. Constrained or tight areas may not permit the use of a self-contained breathing apparatus, even though it might be an acceptable choice. Likewise, working around obstructions or moving machinery that can snag hoses may limit the use of airline respirators. The user of the respirator is another important factor when considering selection of a respirator. Wearing respiratory protection poses a physical burden on the wearer. When a worker's medical condition would prohibit restrictive breathing conditions, negative pressure respirators would not be an appropriate choice. Worker preferences should also be a consideration during the respirator selection process. Among air purifying respirators, powered air purifying helmets have been subjectively rated the best for breathing ease, skin comfort, and in-mask temperature and humidity, while filtering face pieces are rated high for lightness and convenience. Each, however, has its own drawbacks, and all factors should be taken into account during selection. The assigned protection factor, or APF, of a respirator reflects the level of protection a properly functioning respirator would be expected to provide to a population of properly fitted and trained users. For example, an APF of 10 for a respirator means a user could expect to inhale no more than 1/10 of the airborne contaminant present. APFs must be utilized to ensure a respirator meets or exceeds the required level of employee protection. OSHA enforces the APFs listed in its standards, unless an alternate APF has been granted by a specific OSHA interpretation. There are two types of respirators: air purifying and atmosphere supplying. Only use respirators appropriate for the chemical state and physical form of the contaminant. Air purifying respirators have filters, cartridges, or canisters that remove contaminants from the air by passing the ambient air through the air purifying element before it reaches the user. The type of cartridge and the particular hazardous substance for which it provides protection is identified by labeling and a standardized color coding of the cartridge. These respirators are also known as negative pressure respirators because of the negative air pressure created by inhalation. They offer no protection against oxygen-deficient atmospheres. A leak-proof seal between the facepiece and the worker's face is essential for proper protection. Leaks may be caused by improper fit, the presence of facial hair or foreign substances under the sealing surface, or cracked or damaged seals, valves, or cartridges. There are three different types of air purifying respirators: a particulate respirator, a combination respirator, and a gas and vapor respirator. A particulate respirator captures particles in the air, such as dusts, mists, and fumes, but will not protect you from gases or vapors. This type of respirator generally becomes more effective as particles accumulate on the filter and plug spaces between the fibers. A common dust mask is considered a particulate respirator. A combination respirator is normally used in atmospheres that contain hazards of both particulates and gases and have both particulate filters and gas vapor filters. A gas and vapor respirator is normally used when there are only hazardous gases and vapors in the air. These respirators use chemical filters, referred to as cartridges or canisters, to remove dangerous gases or vapors and protect against specific gases or vapors, not airborne particles. This type will provide protection only as long as the filter's absorbing capacity is not depleted. These are generally equipped with an end of service life indicator, or ESLI, certified by NIOSH to warn a user of the approaching end of adequate respiratory protection. If no ESLI is present, a change schedule is necessary. The change schedule is part of the written respirator program and states how often cartridges should be replaced and what information was relied upon to make this judgment. The service life of the filter depends upon many factors, including environmental conditions, breathing rate, cartridge filtering capacity, and the amount of contaminants in the air. A safety factor should be applied to the service life estimate to assure the change schedule is a conservative estimate. Safety factors are reductions to an estimated service life to ensure the actual service life will not be exceeded. An atmosphere-supplying respirator supplies clean air directly to the user from a source other than the surrounding air. This type is also known as positive pressure respirators. A supplied air respirator, or SAR, a combination respirator, and self-contained breathing apparatus, or SCBA, are the three different kinds of atmosphere-supplying respirators. A SAR makes use of a hose to deliver clean, safe air from a stationary source of compressed breathing air. The supplied air respirator provides clean breathing air for long periods of time and is lightweight for the user. However, this type of respirator limits user mobility and range due to the attached hose. Failure, though uncommon, can happen if the hose gets damaged. The SAR is sometimes called an airline respirator. Usage is normally limited to when there is extended work periods required in atmospheres not immediately dangerous to life and health. A combination respirator has an air supply component, plus an auxiliary self-contained air supply to be used if the primary supply fails. The self-contained portion can be small, since it only needs to supply enough air for escape, and usually has enough breathing air for a few minutes in a self-contained tank. These respirators can be used for entry into confined spaces and are normally used when there is extended work periods required in an IDLH atmosphere. A self-contained breathing apparatus, or SCBA, is similar to a scuba tank. The SCBA is commonly used in firefighting and can provide breathing air for an extended period of time. The SCBA consists of a wearable, clean air supply pack and doesn't restrict movement with a hose connection. The closed circuit type can provide breathing air up to 4 hours. The open circuit type only provides air for 30 to 60 minutes. And finally, the SCBA is normally used when there is a short time needed to enter and escape from atmospheres which are or may be immediately dangerous to life and health. Never enter an area designated to be immediately dangerous to life or health, or IDLH, without a proper respirator and training on the atmosphere. All oxygen-deficient atmospheres are considered to be IDLH. Respirators considered for use in an IDLH atmosphere are a full facepiece pressure demand SCBA, certified by NIOSH for a minimum service life of 30 minutes, or a combination full facepiece pressure demand supplied air respirator with auxiliary self-contained air supply. Respirators provided only for escape from IDLH atmospheres should be NIOSH certified for escape from the atmosphere in which they will be used. Other rules may apply to entering an IDLH atmosphere, such as special training, rescue and entry procedures, and additional personnel. Using a respirator may place a physiological burden on employees. The effects can vary with the type of respirator worn, the job performed, workplace conditions, and the medical status of the employee. Some conditions may adversely affect the health of employees who wear respirators and include negative pressure respirators, which restrict breathing, self-contained breathing apparatuses, which are heavy and bulky, and some respirators can cause claustrophobia. Employees need to be medically cleared to wear respirators before commencing use. A physician or other licensed healthcare professional needs to medically evaluate employees to determine under what conditions one can safely wear a respirator. All respirators that rely on a mask-to-face seal need to be fit tested on an annual basis. The test can either be a qualitative or quantitative method to determine whether the mask provides an acceptable fit to a wearer. The qualitative fit test procedures, often referred to as QLFT, rely on a subjective sensation of the respirator wearer, such as taste, irritation, or smell to a particular test agent. Qualitative fit testing is accomplished by temporarily converting the respirator user's actual facepiece into a negative pressure respirator. The quantitative test, often referred to as QNFT, uses measuring instruments to measure face seal leakage. Quantitative fit testing is accomplished by modifying the facepiece to allow sampling inside the facepiece in the breathing zone of the user, midway between the nose and mouth. Any modifications to the respirator facepiece for fit testing must be completely removed and the facepiece restored to the NIOSH-approved configuration before the facepiece can be used. The relative workplace exposure level determines what constitutes an acceptable fit and which fit test procedure is required. For negative pressure air purifying respirators, users may rely on either a qualitative or a quantitative fit test procedure for exposure levels less than 10 times the occupational exposure limit. Exposure levels greater than 10 times the occupational exposure limit must utilize a quantitative fit test procedure for these respirators. Fit testing of tight-fitting atmosphere-supplying respirators and tight-fitting powered air-purifying respirators shall be accomplished by performing quantitative or qualitative fit testing in the negative pressure mode. A record of the fit test must be retained until the next test is administered. It is recommended, however, to retain all fit testing records. The record must include name of employee tested, type of test performed, specific make, model, style, and size of respirator tested, date of test, the pass or fail results for QLFTs, or the fit factor and strip chart recording or other recording of the test results for QNFTs. Employees who use a tight-fitting respirator must perform a user seal check to ensure an adequate seal is achieved. The seal check is to be performed each time the respirator is used. Both a positive and a negative seal check are required. User seal checks are not substitutes for qualitative or quantitative fit tests. A positive pressure check is performed by closing off the exhalation valve and exhale gently into the facepiece. The face fit is considered satisfactory if a slight positive pressure can be built up inside the facepiece without any evidence of outward leakage of air at the seal. For most respirators, this method of leak testing requires the wearer to first remove the exhalation valve cover before closing off the exhalation valve and then carefully replacing it after the test. A negative pressure check is performed by closing off the inlet opening of the canister or cartridges by covering with the palm of the hands or by replacing the filter seals, inhaling gently so the facepiece collapses slightly, and hold your breath for 10 seconds. The design of the inlet opening of some cartridges cannot be effectively covered with the palm of the hand. The test can also be performed by covering the inlet opening of the cartridge with a thin latex or nitrile glove. If the facepiece remains in its slightly collapsed condition and no inward leakage of air is detected, the tightness of the respirator is considered satisfactory. All manufacturers of respirators provide recommended user seal check procedures with their instruction sheet. The respirator manufacturer's recommended procedures for performing a user seal check may be used instead of the positive and/or negative pressure check procedures provided by the employer. Demonstrates the manufacturer's procedures are equally effective. The proper functioning of respirators and ensuring the devices themselves do not pose a hazard to the user require an ongoing and regular maintenance and cleaning schedule. In general, respirators should be inspected for basic function prior to each use and cleaned as often as necessary to prevent the occurrence of unsanitary conditions. Inspect respirators used routinely before each use and during cleaning. Respirators maintained for emergency use should be inspected monthly and according to manufacturer's recommendations. Emergency escape-only respirators should be inspected before being carried into the workplace for use. Respirators issued for the exclusive use of an employee should be cleaned as often as necessary to be maintained in a sanitary condition. Respirators issued to more than one employee or worn by more than one employee should be cleaned and disinfected before being worn by different individuals. Respirators maintained for emergency use should be cleaned and disinfected after each use. Respirators used in fit testing and training should be cleaned and disinfected after each use. Self-contained breathing apparatus, SCBAs, must be inspected monthly. Air and oxygen cylinders must be maintained in a fully charged state and should be recharged when the pressure falls to 90% of the manufacturer's recommended pressure level.